Welcome Pure Math 3 students to week 13 of maintenance. Most of the questions today are exam questions. I think there's one or two that might be from a textbook. This one here is on partial fractions, and so I want to rewrite this so that I've got a over 1 minus x plus b over 2 minus x plus c over 2 minus x all squared. That's what I'm trying to do. And therefore, to find a, b and c, I'm going to times the a numerator by 2 minus x squared. It's a squared here, isn't it? Then I'm going to times the b numerator by both 1 minus x and another 2 minus x. And that would give me this here. And then the c numerator I'm going to just multiply by 1 minus x. Now, this will give us x squared minus 8x plus 9. Now, we'll just do a few test cases here. The first one, I'd say let x equal 2. And you can see immediately that that will wipe out the a's and the b's and just leave you with c, because you get 2 minus 2 is 0, 0 times anything is 0. So that means we get 1 minus 2, so we get negative c equals, now we insert the 2 into this function here, 2 squared, take away 8, plus 9. So I get c, so 4, hang on, what have I done? Oh, you take away 8 times 2 plus 9. So I think that gives us negative 3. So I get that c is equal to 3. And then I can also get rid of both b and c by saying let x equal to 1. And you can see that 1 take away 1 gives you a 0 here, and 0 times anything is 0, and the same there. So those would drop out. And this will just leave me with a. So if I look at a now, I go 2 minus 1, which is 1. 1 squared is 1. So I get a. And then I just pop in 1 to this formula here. So a will equal to 1 squared, take away 8, plus 9. Take away 8 times 1, plus 9. And so I get a is equal to 2. Because 1 take away 8 is negative 7 plus 9 is positive 2. And now that I know this, I can equate the coefficients for the x squared term to find b. So if you look at the x squared term, it's made up of a times negative x, so that's going to be a x squared. And we know that a is 2. We'll do that in a second. And then the only other way you can make it is b times negative x, which is going to be bx squared. And that ought to give us this here, which is x squared. And now we know that a is 2, so I get 2x squared plus bx squared equals x squared. So therefore b is equal to negative 1. Oops, Zoom's gone funny. Okie dokie. So now we can write that as 2 over 1 minus x minus 1 over 2 minus x plus 3 over 2 minus x all squared. And that would be expressing the original function in partial fractions. Okay. Now, hence obtain the expansion of fx and ascending powers of x. Okay. So this one's nice and easy, so we'll do this part first. We can rewrite that as 2 into 1 minus x all to the power of negative 1. And we can expand that as 2 into 1 plus, now we take the power, negative 1, we multiply it by negative x, that's just to the power of 1. And then we go plus negative 1, drop a power down, pop that over 2 factorial, and then we get our negative x, and we're doing that to the power of 2. That's as far as we need to go. If you're a bit hazy on this, you might want to go back to the appropriate chapter in your textbook. And then we can expand that out, so we get 2 plus 2x And what is this last one? Negative 2 times negative 1. Positive 2 over 2 factorial is 1. Ah, yeah. So when we expand it, we'll get 2x squared. So that's nice and easy one, that one. The next one we're going to write as minus 1 bracket 2 minus x. Now to the power of what? Negative 1. And remember, we can't expand it when we've got a 2 here. We want it 1 there. So we're going to go minus 1 times, and then going to go 2 to the negative 1. I've factorized it out, so I get a 1 here, and then I get an x over 2 here, and that's to the power of minus 1. And hopefully you can see that that will become negative 1 over 2, because 2 to the negative 1 is just 1 over 2. And then we've got 1 minus x over 2 to the power of minus 1. So we're just going to expand that now, and that's like negative 1 over 2 square bracket 1 plus, and then we go the power, negative 1, whoops, times the second term to the power of 1, and then plus negative 1 times, getting a bit messy there, negative 1 times negative 2 all over 2 factorial, and then times negative x over 2 all squared. Now, when we expand that out, we're going to get negative 1/2. Now, the second term, negative, so that becomes positive x over 2, and when we times that by negative 1/2, we're going to get negative x over 4. And the last one, what do we get? Well, this resolves to 1, and then we've got negative x over 2 squared, which is positive x over 4. So when we multiply that out, we get negative x squared over 8. So that's that one. Now the last one is this one here. Whoops, that was meant to be a highlighter, but you get the general idea, that one there. So we write that as 3 bracket 2 minus x to the power of negative 2. And we want to take that 2 out so that we've got 1 is that first numeral there. So 3 times, I take the 2 out, again 2 to the minus 1. And then in my brackets that will leave me with 1 minus x over 2 to the power of, oh, and it shouldn't be to the power of negative 1 this time because there's negative 2 on the outside, so that 2 should be to the negative 2. And then we've got a negative 2 here. So 3 times 2 to the negative 2 is 3/4. And then I'm going to expand this bracket. So I get 1 plus negative 2 is my power, and I'm going to multiply that by the negative x over 2 to the power of 1. Then my next term would be plus, I take the negative 2, I times it by the next power down, negative 3, I pop that over my 2 factorial. And then negative x over 2 this times squared. Now we're ready to expand this. Well, the first term is nice and easy, it's 3/4. The next one, you can see that you've got negative 2 times negative x over 2, which is just positive x, and we times that by 3/4, so we should get 3/4 x. 3/4 x. The last one, you're going to get positive 3 from this bit here, and then you'll get x squared over 4, so that's 3/4 x squared, and then you times it by 3/4 again, so that's positive 9/16 x squared. Now all that we need to do at this point, man, what a long question, we're just going to add all of the like terms together. So 2 minus 1/2, 3/4. So what does that give us? 2 and 3/4, 2.5, or 5 over 2, I guess is another way of writing it. So say, is that right? I'll pop them all in quarters, so 8, 11, 9 quarters. 9 quarters. And then maybe we'll look at another one here. We've got 2x, and then we got negative x over 4, and then we got 3/4 x. So that's that one is 5 over 2x, that one. Yep, 5 over 2x. Yeah, 5 over 2x. And then finally, positive 2x, take away a quarter, an eighth x squared, and then 9 over 16x squared. Now that ends up being, let's put them into 16ths, 32, take away 2, 30, 39. 39 over 16 x squared. Alright, that was a bit of a long question, wasn't it? Okay. Now the next one, I've got to solve this inequality. Just check this is still working. Oh yeah, it is working, that's good. Now we're just going to use the method of squaring both sides. So I will first of all square, and that will get rid of this modulus, so everything's positive at this point, so we get 9x squared minus 6x plus 1 less than 4x squared plus 20x plus 25. I'll bring everything across to one side. So 5x squared minus 26x minus 24 is less than 0. I'm going to factorize that, I think. Yeah, 5x x 6 is negative 6 is 30. Negative 30 plus 4. Okay, now at this point, I know that I've got roots at negative 4/5 and 6. So something like this, something like this. And we're wanting where is this less than 0. So it's less than 0 between those two values. So for us to finish off and solve the equation, we just go negative 4/5 is less than x is less than 6. We want that spot there. Okay, next one is a logarithmic and exponential functions question. So for this one, I'm going to put them both in terms of the natural log. So I would have my second line looking like this. I'll say, well, that's like natural log of e to the 2. Now I can get rid of the logs because we've got log something equals log something, so we get 2 plus e to the negative x equals e to the 2. I will rewrite this as 1 over e to the x equals e to the 2, and I'll subtract 2 from both sides. Then I'll say 1 equals e to the x multiplied by e to the 2 minus 2. Then I'll get e to the x by itself. E to the x equals 1 over e to the 2 minus 2. Then I'm going to take the natural log of both sides, which will give me x equals natural log of 1 over e to the 2 minus 2. And I'll pop that into my calculator. What will I get? ln 1 over e to the 2 subtract 2. I'm getting negative 1.68. Okay, the next one is a trigonometry question. And we've got to show that this cosine theta minus 60 plus cosine theta plus 60 is equal to cosine theta. So we're looking at the cosine addition rule. Okay, so the first one is subtract. So that is cosine theta cosine 60 plus sine theta sine 60. So this is just that bit. And now we're going to do the next bit. Plus cosine theta cosine 60 minus sine theta sine 60. So this is this. Now hopefully you can see at this point that we're going to drop this bit and this bit cancel each other out. And we know that cosine 60 is 1/2. So we get 1/2 cosine theta plus, and over here we've got another one of those, 1/2 cosine theta. And that is equal to cosine theta. So that's nice and easy. So the next part here, given that blah, 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 blah. Okay. Now, we've got to find the exact value of cosine. Now, we know what this bottom bit of the equation is, don't we? This here is what we've just found to be cosine theta. So, my first step might be to say, all right, cosine 2x minus 60 plus cosine 2x plus 60 all over cosine x, not theta because we're doing x's this time, equals 3. Or I could even just go straight to, just move that cosine x straight across the other side, equal to 3 cosine x. Okay, now at this point, if we look at this left-hand side, we ought to see that this is actually very similar, isn't it, to this bottom line, except this time we've got 2x. So we can now go, therefore, this left-hand side we can rewrite as cosine 2x. And at this point, you should be able to see, hang on, now we're using this thing here, aren't we? Now we want to find the exact value of cosine x. So I want to just get everything in terms of cosine. So I'm going to choose this version of the double angle rule for cosine. So I'll get 2 cosine squared x minus 1 equals 3 cosine x. I'm going to bring everything across to one side. So I'm forming now a quadratic. And to find out what cosine x is, I can now, of course, use my formula, quadratic formula. So cosine x equals minus minus 3, or positive 3, plus or minus the square root of minus 3b squared, minus 4 times a, which is 2, times c, which is negative 1, all over 2 times a, which is 2 times 2, which is 4. And this will give us 3/4 plus or minus, now if we work out under the square root there, that's 9 plus 8, which is 17, and that's also over 4. Now we've got two answers, but one of those answers actually isn't going to make sense, so just check the value of them. 3/4 plus the square root of 17 over 4 is actually going to give me a number that's greater than 1. So we can't include that because cosine x is undefined for anything greater than 1. So the only value that we can write down as our final answer here is 3/4 minus the square root 17 over 4. Okie dokie. So moving on to our differentiation question. This is parametric equations. And I've got to show that when I differentiate, that dy dx is equal to this. Okay, that looks rather complex, but what we're going to do is we're going to start off with this one, and we're going to go, all right, dx d theta, and that's nice and easy. That's 6 squared theta. Okay. Now this one's a little bit more complex because we're going to have to use the product rule. So u is equal to 2 cosine squared theta, and we're going to work out du d theta in a moment. V is equal to sine theta, so dv d theta is equal to cosine theta. Now let's just take a little bit of a break here in a different color pen, and we're going to differentiate this side here. So we're going to say, let's just do another u. I know maybe I should use another letter, but I'm just going to use u for the moment. U is equal to cosine theta, and du d theta in this case, so we're using the chain rule here, that would be negative sine theta. And then v is, sorry, not v, y is equal to 2u squared. And so dy d theta would be equal to 4u, in this case 4 cosine theta. Therefore dy d theta is equal to 4 cosine theta times negative sine theta, which is negative 4 cosine theta sine theta. Now, just make this a bit smaller. Okay, so that means that du d theta is equal to negative 4 cosine theta sine theta. Okay, now we can use the product rule. The product rule and work with this. So dy d theta is going to be equal to u times dv d theta. So that's this one times this one. So that's 2 cosine cubed theta plus v, this one, times this one, which is minus 4 cosine theta sine squared theta. Okay, now we can start thinking about our parametric equations. So we've got dx d theta here and dy d theta, but we want dy dx. So dy dx is equal to dy d theta multiplied by d theta dx. Okay, they're not fractions, but we can think of them like that for our purposes. So that's like saying 2 cosine cubed theta minus 4 cosine theta sine cubed theta, squared theta, sorry, all over sec squared theta. But sec squared theta is 1 over cosine squared theta. So we can simplify this as 2 cosine to the 5 theta minus 4 cosine to the 3 theta sine squared theta. Now at this point, you can see that what we're trying to get over here is actually all in cosine. So I'm going to, in my next line, go 2 cosine to the 5 theta minus 4 cosine cubed theta into 1 minus cosine squared theta using the identity that we learned in Pure Maths 1. And this gives us 2 cosine to the 5 theta minus 4 cosine cubed theta plus 4 cosine to the 5 theta, and that gives us exactly what we want, which is 6 cosine to the 5 theta minus 4 cosine cubed theta. And we're done. That was a really tricky one. Hope that makes sense. You might want to re-watch that and look at the approach that we took again. Okay, so this next one, this looks like a textbook example, so it'll be a bit easier. We're going to integrate this. Now, when we integrate this, I'm going to say, look, it's going to be ln bracket 2x plus 1. And how did we get that? 4, well, it must be 2 in front of it. So that would be what I'd do for this, and then I'm going to pop my brackets around it. And then that gives me 2 ln, 2 times 3 is 6 plus 1 is 7, 2 ln 7, take away 2 ln 3, which is like saying ln 49, because 7 squared, take away ln 9, which is 3 squared, and another way of writing that is ln 49 over 9. Okay, brilliant. Next one, last one, numerical solutions. Okay, we've got to show that this has a root. So I would first of all say, let fx be equal to e to the x plus x minus 6. And then say f1, what does this equal? Now f1, when I type this into the calculator, I'm getting negative 2.28. And then when we pop in a 2 to this function, we get a 3.39. The sign change between x equals 1 and x equals 2 tells us a root lies between these values. Okay team, so for this next one, my first step would be to rewrite the equation e to the x equals 6 minus x. Then I would take ln of both sides, so ln of e to the x equals ln of 6 minus x, okay? And then, at this point, I know that ln of e to the x is simply x, and then I've got ln of 6 minus x. Okay, so that's all done there. Now we're going to use the iterative formula and to calculate the root. Well, we know the root lies between 1 and 2, so I'm going to start my first value as x equals x1 equals 1.5. Now in the calculator, I type 1.5 equals, and then I can press the orange button, and I've got my, that's now set as my answer. So at that point I would go ln 6 minus ans. This is on the Casio that we've got. Alright, and let's see what we get. So 1.5 equals, orange button, ln 6 minus ans. Okay, so my x2, 1.5041, my x3, 1.5032, my x4, 1.5033, my x5, 1.5033, you're getting the idea. My x6 equals 1.5033, my x7 equals 1.5033. Yeah, we see that you always go a little bit further than you need to, just to ensure. So therefore x is equal to 1.503 to 3dp. Alright team, that's the end of week 3 maintenance. I hope that's been helpful to you. God bless and see you next time.